Okay, I'll get started. I'll briefly introduce you to POLARDB, which is a cloud-native database developed here at Alibaba. My name is Manyi. I'm currently leading POLARDB for MySQL effort, as well as the RDS effort. Before joining Alibaba, I used to work for Oracle MySQL team, leading the optimizer team. So, what's the motivation behind POLARDB? As I said, AliCloud has long experience offering relational database as a service, the RDS. Based on that experience, we know that, for instance, MySQL RDS has been a huge success at AliCloud. However, it has some limitations. MySQL as a database, or relational database in general, were developed more than 10 years ago, built for on-premise usage. It's not able to utilize all the possibilities what cloud infrastructure has to offer, or achieve the scalability that the cloud scale requires. So that's the motivation behind a new database called POLARDB, where we strive to build the most advanced and easy-to-use cloud database for our customers. There are a few characteristics I would like to dive into. Emerging hardware as unique for a cloud vendor because we do control the data centers. So we know what we can choose the hardware optimized for database usage. At the same time, we can optimize the software exactly for the hardware that are available in the data centers. This kind of co-design is not possible to achieve on-premise. However, it's our starting point for cloud database. Auto-scaling is also what's a common requirement for our cloud users. Think about a retailer as a customer. On Double 11 in China or Black Friday in the US, maybe that on that single day, 30% of annual revenue occurs on that day. On that day, if you want to scale your entire database platform for that single day, you need to over-provision the rest of the year. That's not needed if you run on cloud. We can scale up and down based on customer demand. For customers, you only pay as you go. I'll get back to that later on. Security may be a concern for many, although rest assured, we do offer encryption, audit, access control, a long range of security features. Intelligent is the key because cloud is all about economy of scale. We manage hundreds of thousands, millions of database instances. On that scale, we need automation. So extensive monitoring platforms is in place. And that is used as basis for self-diagnostic, self-healing, and auto-management. Without that, we will never be able to manage 10 millions of instances of servers. So the cloud architecture that we have chosen has three layers. On the top, we have intelligent proxy. In the middle, we have a POLARDB, which is a database layer. The PolarFS is a file system designed in particularly for POLARDB. And at the bottom, we have the storage layer, PolarStore. The PolarStore is a common storage layer for multiple databases and instances. It's shared storage. While the POLARDB and the proxy layer are not shared among customers. Customers decide on their own how many instances they want. Well, on PolarStore, since it's shared, we can have incredibly good scaling on the PolarStore. On the architecture level, if we go do a deep dive into a PolarStore, on this figure, you can see that on the bottom layer, we have multiple trunk servers. That's storage layer. So data on host 1, there are 2 instances. PolarDB can use the local PFS to direct data into trunks. And the Polar Switch will direct the data trunks to physical storage nodes. For each trunk of data, there are 3 copies in the storage layer for redundancy, for HA purpose. And we use a parallel ref protocol to synchronize between 3 copies of the same trunk in the storage layer. Well, as I said before, we utilize some of the most advanced hardware in the system. For the storage system, we extensively use RDMA, both between storage nodes and between compute node and storage node, meaning that in practice, networking is no longer a bottleneck for our system. In addition, we also use a combination of open SSD and NVMe SSDs to achieve low latency and high throughput. Dynamic scaling, how do we achieve dynamic scaling? On the top left figure, we have MySQL RDS service. MySQL RDS service uses shared nothing architecture, meaning that data is flushed to local storage. So every time you create a new read-only replica, you actually need to copy the data into a new instance. And that if an instance has multiple terabytes of data, the copy will take some time. POLARDB, as opposed to RDS, MySQL RDS, is shared disk. So there's only one copy of data, or besides, for redundancy purpose, we do have multiple copies, but that's a different thing. From architecture level, you don't only one copy of data in the shared storage. If we add a read-only replica, there's no data copying involved. We can just create a new compute instance and attach that to the existing storage. So for that, we can create a new read-only replica in minutes. The time it takes really, really about provisioning a new instance. From cost perspective, if there are multiple, everything beyond 1, 2, 3 read-only replicas, POLARDB has a cost advantage. How many people in the room are familiar with MySQL? Raise your hands. Okay, we have more than half, 50% of people. So on the left-hand side, we have the traditional MySQL replication. It's just logical replication, so bin log-based replication. If you look at the I/O generated between the database and the storage, on the master, we need to flush data asynchronously. Of course, we need to write read log into the storage. In addition, there's bin log. Bin log is the physical replication. It also needs to be transferred from master to slave. On the slave side, even more I/O. You have the read log and data. In addition, you need to write the master's bin log and the slave's own bin log to storage. We in POLARDB moved away from logical replication. We do support logical replication, but we don't rely on logical replication for internal purpose. We use physical replication using read log. So master will write read log to a data to PolarStore, and from PolarStore, slaves or read-only replicas will read the read log, and we use that to recreate the buffer pool, the pages in the buffer pool. In database terms, we call that in the slave. A slave is actually running on continuously recovery mode because it's constantly applying read logs. So what's the benefit of physical replication compared to logical replication? In the extreme case, we have DDL operation, create index in this case. That can take 1 hour, which is not uncommon. On the left-hand side, we have a logical replication of MySQL RDS. So in that case, on primary, the DDL is a non-blocking operation, meaning that you can concurrently as the DDL is being executed, you can have insert delete update running against the same table. However, the replication scheme means that all the updates, concurrent updates, will be blocked on the slave side until the DDL operation, the create index operation, is completed on the master. So if the DDL operation takes 1 hour, concurrent DML will be blocked for 1 hour. This causes significant replication lag. That's not the case as shown on the right-hand side for physical replication, since we only have one copy of data. The primary and the read-only slave will read the same copy of data. Of course, we still need to acquire the DML lock and up to the dictionary cache, but there is no blocking, not on the master, not on the slave. In terms of replication lag, RDS has no upper limits because of DDL operations, or in case of POLARDB, we're talking about maximum milliseconds. Parallel query, and we also improved the query performance of MySQL significantly, because MySQL only handles query processing in a single-threaded fashion on the compute node. POLARDB, now in the coming version, will support parallel query, meaning that we can start multiple worker threads and that we can collaborate to execute the query. Currently, we support a single master mode, but going forward, we are in the progress of working on a multi-master version. In single master version, we provide the customers a single endpoint, and the proxy will handle load balancing, transparent failover, and cache consistent read. You can have one master plus 15 slaves, all of them attached to the same shared storage. The proxy will also handle cache consistent read, meaning that client can read their own write. Since I'm running out of time, I won't go into detail how I handle that. Anyone has any questions, we can take at the end of the session.